All right, let's dive straight into this explainer. We're going to simulate a massive, high-stakes race between four of the most extreme machines on Earth to uncover the extreme physics of speed. We'll be breaking down the science, the engineering, and the raw physical forces that dictate exactly what happens when you push machines to their absolute limits.
Think about it. If you line up a multi-role fighter jet, a track-only hyperbike, and two world record-holding hypercars side by side, who actually wins the race to the elusive 500 kilometers per hour mark? Well, to figure that out, we're going to follow a simulated drag race from a dead stop, looking closely at the physics that dominate each speed milestone. Because as we'll see, the machine that wins the sprint isn't necessarily the one that wins the marathon.
Section 1. Meet the Speed Titans. Before that light turns green, let's formally introduce our radically different contenders. So, the differences in power-to-weight ratios between these machines are absolutely massive. On one end, you've got the Kawasaki Ninja H2R. It's a track-only hyperbike that weighs next to nothing but packs insane horsepower. Then in the middle, we have the Bugatti Chiron Supersport 300 Plus and the Koenigsegg Jesko Absolute. Now, these guys pack thousands of horsepower, sure, but they're also hauling around the sheer weight of massive engines, cooling systems, and safety tech. And finally, the F-16 Fighting Falcon. It doesn't even measure power in horsepower applied to a road. It's all about sheer jet thrust. And believe it or not, this power-to-weight ratio is going to dictate absolutely everything in the first few seconds of our race. Section 2, the launch. Conquering traction from 0 to 100 kilometers per hour. The light turns green, the race starts, and immediately, this battle is entirely about who can actually grip the road. Because in that initial sprint from 0 to 100, raw power means literally nothing if you can't put it down. The Kawasaki Ninja H2R aggressively leaps into first place, right out of the gate. Its incredible power-to-weight ratio, combined with the incredibly sticky grip of those track-only tires, allows it to just catapult off the line, leaving everybody else in the dust. But wait, what's happening to our million-dollar hypercars? Well, even though the Bugatti and Koenigsegg are throwing down thousands of horsepower, they're momentarily held back by the sheer stubborn physics of pushing heavy mass through rubber tires. They are fighting traction limits, wheel spin, and the slight delays of turbo lag. If they were to just dump all their power at once, they'd vaporize their tires into a very, very expensive cloud of smoke. So they have to carefully meter out that power, and that costs them precious fractions of a second. And meanwhile, our multi-million-dollar fighter jet is actually sitting dead last. Unlike the wheeled vehicles, the F-16 simply cannot instantly apply its massive thrust right off the line. Jet engines take time to spool up, you know? There's no mechanical linkage snapping power to the wheels like a car dumping its clutch. It has to overcome massive static mass purely by forcing exhaust gases backward. It takes a solid moment for that full afterburner to engage, which completely costs it the initial sprint. Moving on to Section 3, mid-range, hitting the aerodynamic wall between 100 and 300 kilometers per hour. Because as that speedometer climbs past 150 and gets closer to 300, the physical forces at play completely change. To really get what happens next, we have to talk about aerodynamic drag. At 300 kilometers per hour, the air isn't just a gentle breeze anymore. It actually acts like a solid wall of molasses. Air resistance increases exponentially as speed rises, meaning this race suddenly shifts from who has the most grip to who can pierce the wind the most efficiently. This is where the Ninja H2R, which totally dominated the launch, hits a literal wall. Why? Well, a human being clinging to a motorcycle is terribly unaerodynamic. They basically turn into a high-speed parachute. At 300 kilometers per hour, horsepower doesn't fight the road. It fights the air. So while the bike is maxing out against this invisible wall, those beautifully sculpted, highly aerodynamic hypercars start reeling it right back in, using their immense power to slice through the wind. Section 4. Breaking the 400 kilometers per hour barrier. As we push past 300 and aim for that terrifying 400 mark, the race positions shuffle dramatically. Remember our lagging jet from the starting line? Well, with its afterburner now fully engaged, aerodynamic drag on the ground is absolutely no match for military jet thrust. The F-16 rockets past everyone with exponential acceleration. At the exact same time, the Bugatti and the Koenigsegg completely overtake the struggling hyperbike, leaving it way behind in a losing battle against wind resistance.
Now, in the battle for second place, we see two totally different engineering philosophies going head-to-head. The Bugatti Chiron relies on brute force and a long-tail design, literally an extended rear end that keeps the car from flipping at extreme speeds. It practically hammers the air into submission. The Koenigsegg Jesko Absolute, on the other hand, is all about finesse. It features an incredibly low drag coefficient, meaning its shape is so incredibly smooth that air just slips right over it with almost zero resistance. It's fascinating. They solve the exact same aerodynamic nightmare in completely different ways. Which brings us to Section 5, the 500 kilometers per hour reality check. Now we are approaching the absolute ceiling of realistic engineering for road vehicles. Getting a car to 400 is insanely tough, but 500? That's a whole different universe. For the hypercars, the aerodynamic drag forces become astronomical. But honestly, the real limiting factor here is the rubber. The centrifugal forces at these extreme rotational speeds threaten to literally tear the tires apart. Plus, to keep from taking off like literal airplanes, these cars require massive aerodynamic downforce, which just pushes the tires even harder into the scorching hot asphalt. It is a vicious cycle that pushes mechanical engineering to the absolute brink of catastrophic failure.
And that right there is exactly why the race ends the way it does. Jet thrust ignores road friction, while wheeled vehicles are fundamentally bound by it. The F-16 easily shatters the 500 kilometers per hour mark because it relies on pure thrust rather than the mechanical friction of a tire gripping the asphalt. It doesn't have to worry about wheel spin, tire expansion, or the heat of the track surface. It just goes.
Section 6, crowning the ultimate champion. With a 500 kilometer per hour barrier totally shattered, we can finally break down our category winners and crown the ultimate champion of this explainer. Look, credit where it's due. The Kawasaki Ninja H2R is the undisputed king of the launch and short-distance acceleration. The Bugatti and Koenigsegg, they tie as absolute marvels of mid-range power and high-speed stability on the road, but when it comes down to overall top speed, the ultimate crown has to go to the sky. The F-16 Fighting Falcon undeniably takes first place overall. While our hypercars are fighting just to hold themselves together at 500 kilometers per hour, the F-16 is capable of pushing past Mach 2. That's over 2,000 kilometers per hour. It wins simply because it is entirely free from the limitations of the road and the pesky physics of rolling resistance. So, here's a thought to leave you with. If our best hypercars are pushing rubber and asphalt to their literal breaking points just to approach 500 kilometers per hour, where does the quest for speed go next? Have we actually reached the final ceiling of what wheels can do? Or will completely new materials rewrite the rules of the road? Keep questioning, keep exploring, and never stop looking at the extreme physics behind the machines.